So just with care, this formula will work. I is equal to 2. So really what you're getting is the value of the y coordinate for those specific x values. Now that's hard to see. It's not the sort of thing that would occur to you, but it does make sense. And what this sigma then is going to lead to as we move on, this is going to give us, taking that point 2 to the front using the property that we've got, we can write this as I is equal to 1 to 9, and then we get 0.2 squared is 0.04 I squared. And this is of form sigma I squared. So according to the formulas we worked out previously for sigma notation, this gives us a way we can simplify it. And in fact, we can go one step further with this. If you take this 0.04 and bring it outside the sigma, it's better still, because now we've got I squared, and if you multiply 0.2 times 0.04, then that number just becomes a passenger outside, so 0.008 from I is equal to 1 up to 9. I'm just going to get a little bit more space to work, but we're getting close. So knowing that, if you recall, for a sigma notation up to n, I is equal to 1 to n, for I squared, this is always equal to n times n plus 1 times 2n plus 1, all divided by 6. So in our case, 0.008 sigma I squared from I equal 1 to 9 is going to be equal to 0.008 multiplied by n, which is 9, times n plus 1, which is 10, times 2n plus 1, which is 19, all divided by 6. And work that out, and I believe you'll get 2.28, which is under what it should be, but it should be fairly close, too. Sometimes 9 times 10 times 19 divided by 6, yeah, so 2.28. Sounds good. So a lot of work to get that under approximation. So we file that one away, and then we go for an over approximation. So now we do the circumscribed rectangles. Now the difference with this one is that the width is still going to be the same, so 10 intervals, so 10 equal intervals, 0.2. But the difference is going to be the endpoint is in the right corner. So the height, or the length, is on upper right corner. So therefore, the upper endpoint of interval. Now, we can deal with that. It just means then that the height for each of these, like for the very last one, is going to be f at 2. And the very first one is going to be f at 0.2. So the intervals are going to be looking like they did before, 0 to 0.2, and then 0.2 to 0.4, and then, etc. like that. But now the length has to be indicated as being f at point 2, etc. like that, point 4, to f at 2. So I'm going to write this out again in a clear way, but that's where this is all going. So I'll get a little more space to work this one out. I think I've got enough below so I can at least get going on this. So the area for the first interval is going to be a width of 0.2 multiplied by f at 0.2. Guess I have an extra bracket there. It's okay. And then the next one is going to be 0.2 width times f at 0.4, and then all the way up to 0.2 times f at 2. Now the big thing that makes this different is that there is no length or height that's going to be 0. So instead of having only 9 rectangles, we're going to have 10. And that's really the key difference, and that's why we get the over approximation with it. So I'll write this out below, that the area is therefore equal to 0.2 times 0.2 squared, using the f at x formula that we've got, plus 0.2 times 0.4 squared, plus all the way down to 0.2 times 2 squared. And then we do exactly what we did previously. We factor out the 0.2, and then we turn it into a sigma notation. Now the sigma notation is going to be very similar to what we had before. But, oops. Okay, got a little crazy on that. So the area, we factor out a 0.2 from each of them, just like we did before, and we get 0.2 squared plus 0.4 squared plus etc. all the way to 2 squared. And then the sigma form we're going to get from that is going to be like this. Area is equal to the sigma from I is equal to 1, this time to 10, because we didn't lose any of them, times 0.2, and the formula turns out to be the same. If this is I is equal to 1, and this is I is equal to 2, to produce that 0.4, or that 0.2, or even the 0.6, all you're doing is you're multiplying 0.2 times I, and then because the formula requires you to square it, you do so. And then this is going to take us to I is equal to 1, from 1 to 10. 0.2 can come out, and so can the point. When you square that 0.2, you're going to get 0.04, and then you'll get I squared left. So it's identical to the previous one except for the extra term. So therefore, the area is equal to 0.08. I is equal to 1 to 10 I squared. And again, we can break that one up by using the formula that we do have. So this is going to be 0.08. Actually, I think I've got an extra 0 for that 4 there. You're probably wondering, where did that come from? And actually, here's where the extra 0 should be. Excuse me. 0.008 is what we're actually looking for. Makes a little more sense. Multiplied by n, which is 10, multiplied by n plus 1, which is 11, multiplied by 2n plus 1, so that's 21. And then all this is going to be divided by 6. So when you simplify that, you'll get 3.08. So the average of the approximations well, 3.08 plus 2.28 divided by 2. So let's file this away and see what we get afterwards. That's 2.68. Now I'm going to stop this lesson right now, just to keep it down fairly relatively short, and then the next part will be doing a better way to get an exact calculation that won't require us to manually break it down into all these intervals. So thank you for your time.